Yes. Good morning, good evening. Welcome back from the break. So, Unit 8 is just talking about applications of trig functions, and one of the applications of trig ratios that you remember is the sine law. The sine law has so many advantages because you can figure out unknown sides or angles of a triangle using the relationship between the sides of the triangles and the sides of the triangles. So just to remind you, this is the law of sines. Sine A over A is equal to sine B over B is equal to sine C over C, and this ratio, this fraction, sine A over A, sine B over B, sine C over C is always equal to some constant. It's always going to be equal to a constant. Constant K. So yeah, it's equal to a constant, and the one at the bottom here is equal to 1 over a constant. What that means is that that ratio of the side to the sine of the angle that is opposite that side is always a constant. That's basically what it means. If I get A divided by the sine of A for a triangle whose sides A and angle A I know, that ratio or that fraction or that number or that decimal is going to be equal to, if I get B divided by the sine of B, is going to be equal to if I get C divided by the sine of C. Now, you might be wondering, how does this sine law come about? How does this law of sines come about? And again, this is mathematics that was discovered by people many years ago. And just showing you a little bit. If this is side A and this is side C and that's side B, if I were to drop a perpendicular from the top of B, if I dropped a perpendicular from B to meet side C at some position, to meet side B at some position, and this is the height of my perpendicular, then I can find expressions for each of these angles in terms of the height. If I start with angle A, I hope you can see that the sine of angle A is equal to opposite, which is the height, out of hypotenuse, for which the hypotenuse, if I'm looking at the triangle AB, let me call this point K. If I'm looking at the triangle ABK, then sine of A is equal to H out of C. So if I try to make H the subject of that, then I'll end up having H is equal to C times sine of A. That's what I get when I make H subject. Now I can do this same thing for angle B. For angle C. If I use angle C, then the sine of C is equal to H divided by A, right? And if I try to make the height the subject, sine of C is H divided by A because H is the opposite and A is the hypotenuse. If I make H the subject, I'll end up having H is equal to A times sine of C, right? H is equal to A times sine of C. This was C sine of A, this is A sine of C. Now if I drop the perpendicular from a different point, from point A, going all the way to B, then I'll be able to make dropping a perpendicular, so I don't know where that would land, probably land somewhere close to here. But the point being, if I dropped a perpendicular from point B, I'd be able to get expressions for B in terms of the other sides. Sorry, for H in terms of the sides, in this case B and A. So since this is H and this is also H, these two things are H, they're the same thing. I can equate them because they're both H. So I can say C sine of A is equal to A sine of C. And if I divide both sides by C, divide by C, divide by C, that gets rid of the C on both sides. If I divide both sides by C, so that cancels out the C, then I'm left with sine A is equal to A sine C divided by C. Then if I go ahead and divide by A on both sides, so if I divide by A on both sides, then I hope you can see that the A cancels out on the right as well. So I end up having the sine law, which is just sine of A over A is equal to sine of C over C. That's basically the proof of the sine law. And I told you that if I use the perpendicular from A to side A, from angle A to side A, or from angle C to side C, I'll be able to get an expression for B, and I'll still end up concluding that all of this is equal to sine B over B, and generally that all of this is always a constant. So that's the proof of the sine law. Now, the sine law works. The sine law works for certain types of triangles. One of those is angle side angle triangle. A triangle in which you have an angle, right? Then you have a side between those two angles, and then you have another angle. So just like what this is showing us, two angles and an included side. This is going to be a review of what you did in 9th and 10th grade. So yeah, you should just be breezing over this. The sine law also works if I have two angles and a side, two angles next to each other and a side, right? The sine law also works if I have two sides and an angle, but we're going to discuss this a little bit more because there's some interesting properties that come up when you start talking about the side-side angle triangle. So let's look at this example. If I want to solve this triangle to the nearest 10th, so I need to give all my answers to the nearest 10th. Solving means I find all the unknown sides and all the unknown angles. So I have angle A, let's check. I have side A, right? This is side A or side alpha. Let me just call it A. I have angle angle Y. Y is, what is it called in Greek? Gamma, I think. Anyways, I have that angle, but I don't have the side. So from the sine law, since I have angle A and I have side A, right? I have angle A and side A. I can use that information together with this angle gamma to find side C. So I know that sine of A divided by A is supposed to equal sine of C divided by C in any triangle, right? So I know A is 50, so I'll just have sine of 50 divided by A is 10 divided by 10 is equal to sine of C. C, the angle that is opposite to C is 30 degrees divided by side C, which I'm looking for. Now, some advice. Every time you're working out these computations or calculations, please solve for the unknown such that you carry all of the values given into the final calculation. What I'm trying to say is, since you have sine 50 here, do not plug in sine 50 in your calculator and then put the decimal number here. Please don't do that. That will increase your error in your answer or reduce your accuracy. So what I advise you to do is go ahead and solve for C. Now I know C is in the denominator here, so if I want to get it in the numerator, I'm going to do this in one step. I would have to go over there in the cross multiplication, right? If it goes over there, that means the 10 has to come over there, right? And the sine 50, that's that side, also needs to move and come or replace replace the C. What I am saying is, I'm doing this in one step because I want you guys to get comfortable doing it in one step so you don't spend so much time solving. What I'm saying is C is directly equal to 10 times sine 30 divided by sine 50. And I'm doing that because, like I said, I want you to be able to do this as quickly as possible so you don't waste time cross multiplying and dividing both sides. I know that's comfortable, but you need to learn to work faster. So mentally what's happening is, first of all, you cross multiplied, right? And just follow along with me. When you cross multiplied, C multiplied sine 50 and then 10 multiplied sine 30, right? So you had C sine 50 and 10 sine 30. Then you divided both sides by sine 50, and then you just end up with C alone equals 10 sine 30 divided by sine 50. So when you plug this into your calculator, when you plug all of this into your calculator, you should have I'll pull out my calculator. 10 sine 30 divided by sine 50. 30 divided by sine 50. I get 6.527, but the question asked me to write my answers to the nearest 10, so my answer is 6.5. The units were not given, so I don't think I need to mind the units. If you're very strict about units, then just add the word 6.5 units. Alright, I've solved for C, yay, but I'm not done because this question asked me to solve for all unknown sides and angles. Now, since I know this angle, I know angle A, and I know angle gamma, I can easily find angle beta using the interior angle sum of a triangle. So I know that angle beta plus 50 degrees plus 30 degrees is supposed to equal 180. And if I do the math on that, again, go ahead and do the math on this, I'll find that B is 100 degrees. Because 50 plus 30 is 80, and when 80 goes to the other side, it subtracts and leaves me with a negative, sorry, it becomes a negative, and 100 minus 80 gives you, 180 minus 80 gives you 100 degrees. So I also have angle B. Now the other thing I need to find is the side B, this side B, which is unknown. So side B, I'm also going to use the sine rule to find side B. I know that sine of B divided by B is equal to, now I can use any of these ones that I've already got, but I'll use A because A has a nice decimal, so I don't want to increase my error in the answer by using a rounded answer. I'm not saying it would be wrong, I'm just saying I know I'll get the most perfect answer if I use 10. So that's sine 50 divided by B. No, sorry, what? Sine 50 divided by 10. Okay, again, I'm going to do the cross multiplication here. The B multiplies sine 50, right? And the 10, B multiplies sine 50, 10 multiplies sine B. Since I want to get B, actually I don't need to move the 10 at all, because the only thing I need to get rid of is the B from the sine B. So, oh, sorry, I need to fill this in. Apologies, I need to fill this in. We know what B is, so we can just go ahead and fill it in. B is 100 degrees. Then all of the stuff I've been going on about can work. So it's 100 degrees, right? Okay, now the cross multiplication. The B goes to the sine 50, the 10 goes to the sine 100, and then I divide both sides by sine 50 to get my B. So B will be 10 sine 100 divided by sine of 50. Okay, if this is complicated, if this is going too fast, feel free to go through the steps one at a time. Remember, we are trying to avoid substituting for the actual values of these functions until the very last step when we're finding the answer, so that we can be as accurate as possible. So that's why we're solving for B, but feel free to take your time. However, just an encouragement that you need to work towards being faster in this, working faster in this. So if I do that on the calculator, I get 12.85, which I round up to become 12.9 units. So I've solved for side B, check. I've solved for side C, check. And I've also solved for angle B, 100 degrees, check. So that's how I solve for a triangle. Yeah. Now, I told you about the SSA triangle, the side-side angle triangle, where I have two sides and one angle. This triangle can present interesting results when we analyze it properly. One of the results is it's possible to not have any possible triangle for the SSA, right? For the same set of values, and I know this may not make sense until I start explaining it better, but imagine a triangle in which you have sides A, B, and C. It's possible that side A is too short to make a triangle at all, because you have two sides B and A. It might be too short, and you have angle A. It might be too short to make a triangle at all. It's possible that you have 0 possible triangles with your side, and angle. It's possible that you have just 1 possible triangle with your side, and angle. Or it's possible that you have 2 possible triangles with your side, and angle. Let me show you this better in this simulation. So in this simulation, this triangle has 3 sides. I have side A, I have side B, and I have side C. So, I'm sorry, angle A. So hope you can see that changes angle A, right? Let's say my angle A is, let me put it at 50 degrees. 50 degrees. Hope you can see that it's 50 degrees. Now, side B. Side B, that is that length. So let me try to change it to something. Let me start with C at 0. So side B can be whatever I want it to be. So remember, I have side angle, or you can think of it as angle side. So I have the angle as 50 degrees. One side is, if I make one side 3, or let me make it 4. Come on, 4. There we go. 4. Yeah, or 8. Or 7. Whatever I want. Make it 8. So if it's 8, there are 2 possible values of the second side that can give me a triangle. What do I mean? This triangle will have a height. Will have a height starting from, and I hope you can see this cursor, starting from that top to the bottom, right? So the conditions for that third side C is, if that side is less than the height of the triangle, then I'm not going to have any possible triangles. If that side is less than the height. So this height of this triangle is, if this side is 8 units and this is sine 50, it's something. You can calculate it. Sine 50 equals h over 8. So height is 8 sine 50, which is 6.1. So if the third side is less than 6, I'm going to move this so you can see. If the third side is less than 6, it will not be possible to have any triangle. And I'm going to post this link on your classroom so you can play around with it as well. If the third side is less than 6, I will not have any triangles at all. If that side is equal to 6.1 or 6.12, the height is 6.128 to 6.13, but this is not letting me get 6.13. Let me try to type it in. 6.128 3555. Okay, it's really close because I didn't do all of the decimals, but you can see that if the third side is equal to the height of the triangle, then if the third side is equal to the height of the triangle, then I have one possible triangle. And let me change this angle to 30 so you guys can see what I'm talking about much better. So that angle is 30. If that side is 8, then the height is going to be a nice 4, because sine of 30 is 4. So if that third side, if the second side is equal to the height of the triangle, then I only have one possible triangle, which is a right angle triangle. But if that height is bigger than the height of the triangle, then I have 2 possible triangles. See that? As soon as the second side that I know in this SSA triangle is bigger than the height of the triangle, then I have 2 possible triangles, because that, and I hope you can see the circle, that side swings around the circle, and there are 2 possible points where it can touch my triangle, my other side, sorry, my base of my triangle. So I keep having 2 possible triangles up to the point where that third side is equal to the first side, right? Okay, at 8. Yeah. So I have one possible triangle if A, the second side is equal to the height, or B, the second side is equal to the first side, right? Because that's an isosceles triangle. And then I have 2 triangles if the second side is bigger than the height, but less than the other side. Hope that makes sense. I hope I've explained it quite well, but I can try to explain it better if you ask me, if it doesn't make sense. Alright, so that's the ambiguous triangle, the ambiguous case of the SSA. And the reason why we're talking about it is every time then you have to think about those conditions and think about whether you have one possible triangle, whether you have two, or whether you have no possible triangles. So let's look at an example. Unknown sides and angles, we have two sides, so exactly right here, we have two sides, we have 8, we have 6, and then we have the angle 35. So how many triangles do you think are possible in this? First, check for the height of the triangle. The height of the triangle, I need to drop a perpendicular here, right? And I know that's height. That's the height of the triangle. So I know that sine of 35 will equal to height divided by 8. And that means that height is equal to 8 sine 35. That means 8 sine 35 is 4.5. So just say 4.6 to round it up. 4.6. That's the second side, which is the 6. So this is the first side. This is the second side. The 6 is bigger than the height of the triangle. Since it's bigger than the height of the triangle, I expect two possible triangles. What that means is that those two possible triangles, one is already what I have drawn, right? One is already what I have drawn. And this is a bad sketch, but just bear with me. One is already what I have drawn, and it has this angle here, which I hope you can see is going to be a supplementary angle, an angle bigger than 90. And the second triangle, the second possible triangle is this one here with an acute angle, right? Yeah, acute and obtuse, sorry. Obtuse angle and acute angle. This is an obtuse angle, and that is an acute angle. So yeah, one triangle will have an obtuse angle, the other one will have an acute angle. Just showing it to you here. In these two possible triangles, one had an angle of 121.6, which is obtuse, or bigger than 90, less than 180, and the other had an acute angle of 58.3. So you'll be required to solve for those two possibilities of this situation. So that's what we're going to do in this example, and everything else is the same as we did before. It's just the knowledge of the ambiguous case of the sine law. Take this out of the way so I have more space. Okay. Moving. Oh, well. Come on. Wasting too much time on this, William. Okay, it's out of the way. Now I can start to solve for one. I'm going to solve for this angle, the obtuse angle, angle beta, and from that I know that sine of beta divided by 8 is equal to sine of 35 divided by 6. Each angle, the sine of each angle on its opposite side. When I do the single step, I have sine beta is equal to 8 sine 35 divided by 6. Since I want beta alone, then beta is going to be the inverse sine. And again, please only substitute all of this in at the last step. The inverse sine of 8 sine 35 divided by 6. So beta is going to be, substitute that in the sine of 8 sine 35 over 6. 49.8. I could say 50 degrees, but it's at nearest 10. So I'll go with 49.8 degrees. So what? Okay, so this is the first part that is interesting. The angle I'm getting is 49.8, but I expect that angle to be the acute angle, right? There's no way this angle is going to be 49.8. So I need to solve for the two possible values of beta. Or according to how this triangle is drawn, I know this angle has to be obtuse. And since this is not an obtuse angle, I'll be looking for the actual obtuse angle. So I'll call this the second possible angle. So the actual value for beta according to this diagram will be 180 minus 49.8. Why? Because sine is positive in two quadrants. Sine is positive in the first and second quadrants, and the angles in those quadrants have the same ratios. So I just need to look for the angle in the second quadrant that will have the same ratio as 49 degrees, and that is 130.1 degrees. 130.1 degrees. So this beta is 130.1 degrees. Remember, since I already have one side, right? I already have one side that's bigger than the height. The second side is also going to be 6. I already have one side that is 6. The other side is also going to be 6. So my triangle is like this, where this is alpha, this is beta, this is the 130, and then that's the 49, and this side is about 6 units. What about this angle? So in the first triangle of the one that's drawn in the picture, I can calculate this angle. Because I know this angle is 130, I can calculate this angle. So remember, I have two solution sets. I can calculate this angle gamma. So just writing this really well so I'm not confusing you. Beta is equal to 130.1 degrees or 49.8 degrees, right? How about gamma? Well, when beta is 130, gamma is, remember, 180 interior angle sum of a triangle. So 35 plus 130.1, and then take that away from 180 is 14.9. That will be 14.9 degrees. And when beta is 49.8 degrees, then I'll still do the same calculation and take away from 180. So I have 35 plus 49.8, and then that is taken away from 180 to give me 95.2 degrees. So yeah, that's it. These are the two possible values of beta and the two possible values of gamma. Now, the other thing I haven't calculated is the two possible values of the third side. Let me call this side C. The two possible values of that third side C. I think I'm going to leave that task with you because that's something you are capable of doing. So what you need to do, just going to show you what you need to do. It helps if you draw out the two triangles. So if you draw out the two triangles, the one triangle has 6 here, 8 there, 35 there, and then you have this angle as in the first triangle, that angle is 14.9. So then you can find that's the value of C. And in the second triangle, this is still 6, that's 8. That angle is 95.2, and then you're still finding the value of C. So you find both values of C and you say beta is equal to this or that, gamma is equal to this or that, and C is equal to that or that. The answers that you will get from these two calculations. Alright, I'm going to move on to the next example. I hope there's not too much fuss about this, but I will still explain it if you have questions. Okay, solve for unknown sides and angles round to the nearest tenth. This is the same example we're doing. So you guys are already pros at this. Good luck doing that. You can go ahead and finish that. Find all possible triangles if one side has a length of 4, opposite angle 50. So I can draw my triangle with angle 50 degrees here, and the side, if one side has a length of 4, opposite angle 50. The side that has a length of 4 is opposite angle 50, so this is 4. and the second side has a length of 10. According to my sketch, which one is the 10? I can make this the 10, right? So the first thing you need to do is figure out the height of this triangle, because it's the height that tells you what you're dealing with. Remember, if the third side is, if the second side is less than the height, right? If the side is less than the height, then you do not have any triangles possible. If it is exactly equal to the height, then you only have one triangle possible. If it is bigger than the height, then you have two triangles possible. So the first step is to figure out how many triangles are possible. So I'm going to find the height of this triangle. So that is h, and sine of 50 is h over 10. So h is 10 sine 50, and I have 7.6. So that height is 7.6. If I drew the sketch like this, that's not good news, because that means that I do not have any, this triangle is not possible, right? So there's no possible triangles if that's the case. Let me see if I can change things up and try to work this differently. But if instead of putting 10 up there, I had put it down here, right? Because still the conditions are still met. I still have the same thing. What if I put the 10 down there? This is just for curiosity's sake, right? So if I put the 10 down there, I would draw the erase. If I put the 10 down there, I would draw my triangle with the height going down that way, right? Going down that way. That would be the height. Just drawing it like that. So if that's the height, still trying to find the height, sine of 50 would still be equal to the height over the hypotenuse, which is 10. So I'll still have sine 50 equals h over 10, and h would still equal 10 sine 50, and that h would still be 7.6, which is still bigger than the second side. So there's no way I can have a triangle with those dimensions. Let me show you practically. Have angle 50 degrees. One side is 10, right? So one side is 10, and one side is 4. The side that's opposite to the angle is 4. So 4, right? If that side is 4, I'm going to show you the circle. There is nowhere, there is nowhere that circle intersects with the base of this triangle in order to make a triangle. So with these dimensions, or with these measurements, I don't have any possible, I have 0 possible triangles. I have 0 possible triangles. So that's your solution. Then there's no possible triangles for this. Finished. Alright, the next idea we'll talk about is the area of an oblique triangle. Oblique is a triangle in which all the sides, okay, it's not isosceles, it's not equilateral, meaning you cannot easily do half times base times height, because, it's not a right angled triangle. You guys are used to calculating the area of a right angled triangle as half times base times height, but an oblique triangle, that's not going to work because it's not right angled. Anyways, too much words. You guys have seen this formula before, again in 10th grade, and it's simply the area of an oblique triangle. The proof is really easy. So just think of, obviously you don't need these proofs, so you can thank me for that. Imagine a triangle in which this is the height. If I make an expression for the height in terms of the side A and the hypotenuse C, right? If I do sine of A, that will be equal to height over C. So I know that height is equal to C sine A. And when I go to find the area of this triangle, area will equal to half, the half that you see here, right? That's the half. Wait, which one do I have? C sine A. Okay, sorry. This is the one I will get according to my triangle which I drew up there. So let me go over it again. The area would be half. The half is already there, times the base. The base of that triangle is B, right? B times the height, but the height of the triangle has been calculated to be C sine A, which is what I have here. So depending on what side you use to drop the perpendicular for the height, you can get this formula in 3 different formats, but it's all the same thing. So just to help you remember it, it's the 2 sides and the sine of the third side. So if these are A and B, then the sine will be of C. If it's B and C, then the sine will be of A. If it's A and C, then the sine will be of B. And you can use that to find areas. So if I want to find the area of this triangle, it will just be half times base times height. Okay, this has been drawn to look like a right angle triangle, but I'm not very sure that it is. So I can't go on assuming that it is. I need to use the area of a triangle formula. So I'll just do half AB sine C. Now since the angle is here, right? Since the angle is here, I don't need to use that side. I'll use the 2 sides that so it's side angle side. I'll use these 2 sides that are sandwiching the angle. So my area will be half times 4.5 times 2.9 times the sine of the third would be the third side, which is the excluded side. So half times 4.5, half times 4.5 times 2.9 times sine 51. That is 5.1 square units. Yeah, you can do the check and see if you just use half base height if it would work. I don't think it would, which goes ahead to tell you that even if it's drawn as a right angle triangle, do not make the assumption that it is a right angle triangle. Even if it's drawn as one, don't assume that it is. Alright, so yeah, that was a long video, but just getting back from the break, so a bit rusty. This is your homework. Have fun. Bye.